everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations with variable coefficients. So let's get going. Problem: solve x square into d square y by dx square minus x into dy by dx minus 3y equals to x square log x to the base e. We are given a differential equation with variable constants, right? Now we'll reduce this to Cauchy's equation. We know that d is a differential operator whose independent variable is x. Then d square will be d squared by dx squared. Now we can write our equation as this becomes x square into d square y minus x dy minus 3y equals to x square log x, right? Now take y common from all the three terms of LHS. We'll get x square d square minus xd minus 3 into y equals to x square log x, which is Cauchy's equation. Okay. Now we'll reduce this equation to linear equation with variable coefficients simply by making a substitution. X equals to e power z and z equals to log x. Let theta equals to d by dz and xd equals to theta, x square d square equals to theta of theta minus 1. Here theta is an differential operator. Okay, theta is differential operator whose independent variable is z. Now this equation becomes, replace x square d square by theta into theta minus 1 minus replace xd by theta minus 3 into y equals to replace x by e power z. You will get e power z whole square into replace log x by z. Okay, then theta into theta, theta square minus theta into 1, theta minus 3 into y equals to e power z whole square is e power 2z into z, right? Then theta square minus 2 theta minus 3 into y equals to z into e power 2z. See, this is of f of theta into y equals to some function of z form. Okay, which is in operator form. Where f of theta equals to theta square minus 2 theta minus 3. Now let's find the general solution to the given equation, which is given by y equals to yc plus y. We now find yc and yp. Firstly, let's find yc using the auxiliary equation. Where f of m is, we have f of theta, theta square minus 2 theta minus 3. Let's replace theta differential operator by m, so that we'll get f of m equals to m square minus 2m minus 3. Now the auxiliary equation becomes f of m, that is m square minus 2m minus 3 equals to 0. Now split minus 2m as minus 3m plus m. Minus 3 equals to 0. Then take m common from the first two terms, we'll get m times m minus 3. And next two terms remains the same. Now take m minus 3 from the two terms, we'll get m minus 3 into m plus 1 equals to 0. Equate each factor to 0. From m minus 3 equals to 0, we'll get m equals to 3. From m plus 1 equals to 0, we'll get m equals to minus 1. Then the roots are m equals to 3 and minus 1, which are real and distinct, or we can call them as real and different. Therefore, m equals to minus 3 and minus 1 are the roots of f of m equals to 0, which are real and distinct. Now let's write the complementary function. When two roots are real and distinct, then yc will be one constant into e power 1 root into z, independent variable, plus another constant into e power another root into z. Now let's write our complementary function. Yc equals to c1 e power 1 root into z plus c2 e power another root into z. Then yc becomes c1 e power 3z plus c2 e power minus z, right? Now let's write yc in terms of x. Okay, for that I'll take this 3 to the power of e power z. We can just write it as e power z whole cube plus c2 e power z whole power 1. Now replace e power z by x, then yc becomes c1 x cube plus c2 x power minus 1. Okay, or yc equals to c1 x cube plus c2 into, you can write x inverse as 1 by x, right? Then you'll get c2 into 1 by x is c2 by x. So this is our yc. Now let's find yp. We'll find particular integral using 1 by f of theta into RHS part. Okay, RHS part of reduced equation. This equals to 1 by f of theta is theta square minus 2 theta minus 3 into z e power 2z, right? And this of 1 by f of theta into e power az into some v form. We'll shift e power az towards left by replacing theta with theta plus a, and later we'll operate b with 1 by f of theta plus a, right? Now let's shift e power 2z towards left. Now compare e power 2z with e power az, then for a equals to 2, we'll get theta plus a, which is equals to theta plus 2, right? Now shift e power 2z towards left by replacing theta with theta plus 2. Then we'll get theta plus 2 whole square minus 2 times theta plus 2 minus 3 into z, right? This equals to e power 2z into 1 by expand theta plus 2 whole square, which is theta square plus 2 square 4 plus 2 2s are 4 into theta 4 theta minus 2 theta minus into plus minus 2 2s are 4 minus 3 into z. Then yp becomes e power 2z into 1 by theta square plus 4 theta minus 2 theta is plus 2 theta. Here plus 4 minus 4 gets cancelled. We'll get minus 3 into z. So this is of 1 by some function of theta into z form, right? Into z per k. Or now write the lowest degree term, the denominator, take the lowest degree term from the denominator common. Okay, we'll take minus 3 common from all these 3 terms. But in the first term, we don't have any minus 3. So what we'll do? We'll just multiply and divide minus 3 to these 2 terms. Okay. So it will be easy to take common in the next step. Take minus 3 common from the 2 terms of denominator. We'll get theta square plus 2 theta by minus 3 plus 1 into z. This is equals to e power 2z into 1 by minus 3 into 1 minus of theta square plus 2 theta by 3 into z. Now we can split this fraction as 1 by minus 3 into 1 by 1 minus theta square plus 2 theta by 3 into z. So this fraction is of 1 by 1 minus x form. So we can write it as 1 minus x whole inverse. Right? And we can write 1 by minus 3 as minus 1 by 3. Okay? So we are going to write this as 1 minus theta square plus 2 theta by 3 whole inverse into z. Now we can write this as minus e power 2z by 3 into 1 minus theta square plus 2 theta by 3 whole inverse into z. Now let's find derivatives of z. Derivatives of z. Theta of z is, derivative of z with respect to z is 1. Theta square of z is, we can write this as theta of theta z, right? Is equals to theta of z value is 1. Then again theta of 1, that is derivative of 1 with respect to z is 0. So d square of z is 0. Likewise d theta cube of z is 0 and so on. All the higher derivatives becomes 0. Right? In general we can write it as theta power k of z equals to 0 for k equals to 2, 3 and so on. Now keeping this in mind, we'll expand this one using 1 minus x whole inverse binomial series expansion formula. 1 plus x square plus so on. For x equals to theta square plus 2 theta by 3, we'll get 1 plus theta square plus 2 theta by 3 plus theta square plus 2 theta by 3 whole square plus so on. This is equals to 1 plus 1 by 3 into theta square plus 2 theta plus 3 square is 9, right? You'll get 1 by 9 into expansion of theta square plus 2 theta whole square is theta power 4 plus 4 theta square plus 2 2s are 4. Theta square into theta is theta cube. You'll get theta power 4 plus 4 theta square plus 4 theta cube, right? Plus so. So in the third term we have higher derivatives, right? Whose value of z is 0. So we can neglect all the terms from here and also the term theta square from the second term. Okay. Now coming to the problem. Expansion of 1 minus x whole inverse is 1 plus theta square plus 2 theta by 3 plus theta square plus 2 theta by 3 whole square plus so on into z. This is equals to minus e power 2z by 3 into 1 plus theta square plus 2 theta by 3 plus theta square plus 2 theta whole square by 3 plus so on into z. So here you are having 3 square, you will get 3 square, right? Is equals to minus e power 2z by 3 into 1 plus 1 by 3 into theta square plus 2 theta plus 3 square is 9, we will get 1 by 9 into theta square plus 2 theta whole square plus so on into z, right? Is equals to minus e power 2z by 3. This becomes minus e power 2z by 3 into 1 plus 1 by 3 into theta square plus 2 theta plus 1 by 9 into expansion of theta square plus 2 theta whole square is theta power 4 plus 4 theta square plus 4 theta cube plus so on into z. Since theta square of z is 0, theta cube of z is 0 and so on, or just let's write in general, theta power k of z is 0 for k equals to 2, 3 and so on. So neglect higher derivatives or terms involving higher derivatives, theta square, theta cube and so on. So we are going to neglect all the terms from here, including theta square from the second term. Okay, then yp becomes minus e power 2z by 3 into 1 plus 1 by 3 into 2 theta into z. Again we can write this as minus e power 2z by 3 into 1 plus 2 by 3 into theta into z. This equals to minus e power 2z by 3 into 1 into z is z plus 2 by 3 into theta of z. We have the value for theta of z, right? Let's place the value. Theta of z is 1, so we have placed the value of theta of z here. This equals to minus e power 2z by 3 into z plus 2 by 3. This equals to, now we need to write all the terms in terms of x, right? We'll change in terms of variable x. So write e power 2z as e power z whole square by 3. We'll just take this 2 to the power of e power z. Now replace e power z by x and z by x, okay, and z by log x. Then yp becomes minus, replace e power z by x, will get minus x square by 3 into, replace z by log x, will get log x plus 2 by 3. So we got yp, which is equals to minus x squared by 3 into log x plus 2 by 3. We can write log x as log x to the base e. Now we are having yc and yp, right? So let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to yc, we have c1 x cube plus c2 by 3, and yp is minus x square by 3 into log x to the base e plus 2 by 3. This completes the problem. So we have seen a problem from higher order linear differential equations with variable coefficients. That is, we have seen Cauchy's equation problem. Hope you'll understand. We'll see you in the next video. Until then, bye bye.